Okay, so what I want to talk about is this wonderful business of bringing some of these old systems sort of kicking and screaming into the 21st century. And what's neat about Unix stuff is that especially the communication protocols and the ideas have persisted since the early 1970s. And so it's kind of unreal that the stuff I use to manage my desktop Linux machine and the laptops that I own and so forth are actually still reasonably applicable. And so the lessons of all of this, what I'm going to show you is a couple of old machines, an old Sun and an old SGI. One of them I boot diskless off of a Raspberry Pi. This is this $35 cheap, don't sneeze, it'll blow off the desk little Linux server. And putting on more storage than anybody in the 90s was dreaming of and so forth. And it all kind of works. Now, the other reason to trust with all of this stuff is that I feel like I learned a lot about sort of what the essence of Unix was and many of the ideas and so forth. And there's more commonality than there are differences, even though, of course, all of the little differences get really annoying. Now, I'll mention two other things. One is if you Google my name, it's Stephen Edwards with a PhD, you'll get these slides, so you don't have to take pictures of these unless you desperately want to. The other thing is the advertisement. When the exhibits get going, I'm in the Unix town or something like that, and I brought these two machines that I'm talking about, and a Raspberry Pi booting, and you can watch the syslogs go and all the rest of that, and I can even advise you about whether this is a good idea or not. Okay, so I have to remember that button doesn't work. Okay, it's about the biggest abstraction I can think of as Unix. It's a program and a file system somewhere. And so the program is the Unix kernel, and it's just a big hunk of code. And the whole goal of all of these machines is to run that big hunk of code. And oh, by the way, one of the things that big hunk of code can do is run all the other programs and all the. But basically, it's the whole game is get the kernel into memory and get it running. And tell it where the hell the root file system is so that it can get at all the other stuff. And by the time you're there, you actually have an interesting working Unix system. Now, normally what you do is when you boot these things up, you pull the kernel off a hard drive, you pull the file system off a local hard drive, and everything's fine. But what's fun is a lot of these systems, essentially most modern systems, of course, but then also the Unix workstation, certainly in the 90s and earlier, had an ability to pull this stuff off of the network. And so what's fun, especially in this days of failing CD-ROM drives and old SCSI drives and all the rest of that, it's really nice to be able to hop in and use networking stuff. So you can run all of this off of a $35 Raspberry Pi with a multi-gigabyte SD card that you just happen to have lying around because that's the kind of person you are. Okay, so here we'll see if I manage to get through all of this. So we're going to put Ubuntu on a Raspberry Pi, and the reason for Ubuntu is that it has all of the wacko servers that you need to get this old stuff working that still work. And so that's kind of nice. Then what I'm going to show you is how to netboot a SPARC Classic, that is to say, boot this thing with no hard drive at all in the machine. And then installing an SGI-02 on a fresh hard drive that I found in the trash. So, very typically, the way one boots a Unix system, and again, this is a big approximation, you'll find many variants and so forth, but you've got some sort of first stage bootloader. And this is a ROM-based thing. This is what has to exist when the thing powers up for the first time. And somehow its goal in life is simply to go and grab the second stage bootloader, which is a smaller program but bigger than the first stage bootloader, typically sucks it off of the disk, hard drive, and then its job is just to suck in the kernel off the disk. Fires that up, mounts the root file system, and then finally runs this init program, which fires everything else off as well. And so there's an interesting question. So the first thing in ROM, yeah, okay, you can't change that, that's built into the machine. The second stage bootloader, you don't necessarily have to get it from the disk. You can often get it from a network. So once you can grab it from the network, then you can do crazy things like, then you can load the kernel off the network, you can then mount the root file system on the network, and in fact, that's what we're going to do. Okay, so what we're doing is taking advantage of stuff that was designed back in the 90s or whatever to do this. You know, they realized, okay, let's not make local CD-ROMs or disks or whatever for all of these. Let's try to put everything on a server, manage it centrally, and things like that. They of course wanted you, if you had a Sun machine, they wanted you to buy a Sun server. If you had an SGI machine, they wanted to buy an SGI server. I suppose we could do this, but I'd rather do it with a $35 Raspberry Pi, which of course blows all of these things out of the water with storage and speed and all the rest of that good stuff. The Raspberry Pi B3 by Pi 3B, go buy one at Micro Center, it's $35. It's really funny, they sell them as loss leaders. The first one, they'll sell them for $35, but if you try to buy two of them, the second one costs $55 or something like that. So they're just trying to lure you in. And it works, it lures me in repeatedly. Anyway, 1.2 gigahertz, 64-bit ARM, gigabyte of RAM, Wi-Fi built in, 100 base T Ethernet, a little slow by today's standards, it ought to be gigabit. There's this pile of operating systems you can get for them. Raspbian is probably the most well-known and standard, but you can also install, and this is what I ended up doing, stock Ubuntu. And that's really nice because that has a lot of packages, and in particular it has the packages we need. And it turns out that I had some issues. All of this, so I'm an academic, so what I'm going to do is present this, oh, it just works perfectly, and I did this, and this worked perfectly. And of course, this is not at all what happened, right? It was, I tried this failed, and that failed, and this failed, and that failed, and I gave up, and tried this, the rest of it. Anyway, I'll tell you the answer. So, go buy one from Micro Center if you haven't already. Okay, so what I'm going to do is sort of just go through a cookbook, do this, do that, do this. But what's interesting is to step back a moment and look at, why do you do this? And how does this do it? And what is this making happen? Okay, so what we're going to do, I just grabbed a 32 gig micro SD card, which is overkill for what I want, but I should be able to put in install images for essentially any operating system I want to. So go and download, half a gig of Ubuntu. This is the magical indentation you needed. Go to Ubuntu, download it, and so forth. CAD it, then use DD to just write it straight to the SD card. Give it some decent block size. F-sync is nice because it means you don't have to remember to type sync at the end to take the card out and so forth. Flash the card, make it so it'll actually boot. Then you got to configure the Pi a little bit. It'll boot up, you need to know the initial password and username and so forth. You can connect it up to the internet. Now, the way I had it set up is, so I have this Pi sitting here, and I want to be able to get at the rest of the network, because I want to download things and move stuff around, and I just use the Wi-Fi connection for that. The other side, I'm using Ethernet, and I'm going to use that to connect up to a switch to the older machines. And so the one thing you got to do is, as usual, it's a modern operating system, so the first thing you do is you fire it up, and you run all of the software updates where it goes and reinstalls all the stuff that you just installed, but it fixes the last bunch of bugs and introduces another bunch. You want to change the host name. They changed how you ask for network configuration stuff with the latest version of Ubuntu. This one, what you do is change a YAML file, and you're running a program called NetPlan, which configures everything. Anyway, tell the Ethernet to be 192.168.1.1, and then this is setting up the Wi-Fi. You probably want to change the SSID and the password accordingly, but this is what you do. And then you can say, oh, fire it away, and with luck it'll fire up and connect everything up. And at that point, you've got a network-connected Raspberry Pi. Okay, so already this is an interesting little object, but let's, this is a vintage festival, so let's talk about this. So I went over to one of my racks and grabbed something hiding in the back, and it was a Sun Spark Classic. This came out in 1992. When was the first Spark? I think it was like 89, 90 or something like that. Yeah. So apparently, 3 years is what it takes for something to become a classic in the computer. Anyway, so 50 megahertz microspark processor, 32-bit, pretty nifty stuff. It doesn't have a heat sink on it. I couldn't believe this. I opened this thing up and was like, what? Really? Anyway. Seems to work fine. It takes relatively standard SIMs, which is nice because these are things you have in your junk box as opposed to having to go and find the phenomenally specific proprietary memory things that the SGIs use.
Does it need parity?
Can't
remember.
Yeah, I can't remember either.
I'm pretty sure it does.
I got into some trouble with it, yeah.
I'm pretty sure it does. I agree. So there's a little bit of complication there.
Yeah.
Not
a little bit. It's not, I think you do have to get sort of, oh, I know what it was, yes. So there's a really interesting failure mode. So if you put non-parity SIMs in and boot it up, it boots up just fine, passes the memory test, but then the Ethernet controller doesn't pass the memory test. What? I couldn't figure that out. I'm saying again?
A little side note on the Spark Classic. If you do decide to clean it, don't shoot canned air at the CPU because those wires are so tiny.
Ah, okay.
They blow right off.
That I can believe it. Yeah.
Just destroyed one like a month ago.
Oh, marvelous. Wow. Okay. Yeah, that's nice. Yeah, fortunately I don't have canned air. Right. And this one was clean enough so I didn't bother. But yeah, good to know. Right, okay. The first Sparks only had AUI ports on. We had to buy mouse and various other things and so forth. This one is actually new enough to have an RJ45 jack in it. So that's really nice. I love these things, and to me the mark of a proper workstation is it has a command line prompt built into ROM in one form or another. So this is Sun's open boot ROM, PROM, whatever. It's actually a fourth interpreter. So Yoda think must you boot Sun with, you get the idea. Anyway, it's a wonderful thing. It's got weirdo video, relatively high resolution, very high resolution for the time. And then it's got this god-awful 13W3 connector, which is a DB25 where they put coax stuff in it as well. And if you ever played with old Suns, you should hang your head and oh yeah, these stupid things. Fortunately, you get adapters that go to VGA and everything works just fine. Now, the problem is this is a weirdo refresh rate, scan rate, or whatever, and so you need the right flavor of modern LCD to make it work. And so, in the process of getting this to work, let's see, about a quarter of the LCD screens I had hanging around worked, and the other quarter didn't. Anyway, okay. So, what we're going to do is make this thing run diskless. I literally went in there and yanked out the 50-pin SCSI connector to make sure that it wasn't cheating somehow. And the whole point is, let's get the thing up and going. The first thing you do when you get a Spark Classic out is you realize that the goddamn real-time clock chip with an embedded lithium cell, of course the lithium cell has died. Now, Bill Hurd was talking about these this morning. The thing I love about these is they don't leak. The whole thing is potted, so you don't have the usual corrode and destroy everything. They just fail kind of peacefully. Now, the beautiful thing is all you need is a Dremel, and you're there. So the way it works is that there's just a coin cell sitting above this chip with some wires in between. And as long as you can see some pictures, I'm sorry, this one isn't very clear, but obviously if you Google and find it, Anyway, you Dremel off the side, you find the leads going up to the internal battery. You discover you probably broke those leads anyway in the process of Dremeling off the stuff. Disconnect the old battery, connect up a new one. This is just a standard CR 2032, which you can find in any modern machine, and you're good to go. Now, one other thing you need to do then, yeah.
If you're inputting it, why not add to the boot script a single ping to NTP and just set the clock then and ignore what it was?
Oh, because there's other much more important stuff in there than just the clock,
Okay.
of course.
Oh, this is the NVRAM then?
Yeah. This is the
Address and everything else.
Yeah. No, this is it's what it is it's a real-time clock plus a tiny little bit of I can't remember how much NVRAM, 2K or some stupid thing, but it has, among other things, the MAC address in it, and so yeah, you can't get around that. Now, of course, when you chop the thing off and after the thing has died, the NVRAM is gone, so you have to go in and refill the NVRAM, including the checksum. And it's at this point that the fourth interpreter gets useful. You go in, and this is the magic incantation. And the important thing here is you give it the MAC address explicitly. Oh, and then you actually write a little function, write a little loop here that recomputes the checksum and makes it so that when you fire this thing up again, it's actually happy. And so this is great. Again, you go read this off the internet or whatever. Anyway, so I tried to write in dead caffeine, but I ran out of bits in the MAC address, so it's dead CC. Anyway, and usually you set the host ID up, and sons are always 8020, blah, blah, blah. Anyway, so this was a wonderful thing, right? When you bring this thing up, and you know, normally when it boots, it'll give you this banner. Anyway, once you fix all of this, you type in the banner at Sun's beautiful serifed but monospaced console font. You see this for the first time. Oh, it's a great feeling.
Beautiful but super slow.
Yes, yeah, yeah. Well, it's kind of like a Kubrick film. It slows you down, sort of brings you into the world. Okay. Next question is, what operating system to put on? There's really sort of two flavors for this machine from Sun. So Sunos, the first one, they stole VSD and implemented that. And it was 92 or something like that, around the time this computer came out, they switched over to the Solaris that's System 5 based. And since I knew about BSD first, I've always been a BSD guy, not a System 5. It's all kind of mushed up at this point, but it all kinds of works. And just to confuse things, they rebranded SunOS as an early version of Solaris. Of course, it wasn't, anyway, marketing. So this is great. We can download the entire installation medium, 40 megabytes compressed. My God. You can find it all over. Of course, World PC has a bunch of this stuff. Take this, when you download it from here, it comes up to this 7-zip format. You can uncompress it, get the ISO out, and then go and mount it locally on the Pi. And so suddenly you've got this install CD hanging around on the Pi, which doesn't even break a sweat. Come on, 40 megs. Okay. The way these Suns work, they've got to figure out what their IP address is. The MAC address is hard-coded, if you will, in the NVRAM. The idea was that it should never change. The IP address, you should be able to set up. Now, the modern way to do this is with DHCP. DHCP didn't exist at this time. It hadn't been invented yet. And so what Sun used was something called RARP, Reverse Address Resolution Protocol. Now, this was a bad idea, and it's long since gone on to the scrap heap of history, but you need a server for it. Now, what's great about Ubuntu is all you have to do is go and ask for the damn package, and it'll give it to you. And so to configure this thing, to make it work so that the Sun, when it boots up, goes and looks and gets its IP address properly, you put the MAC address for the Sun Classic in etc. ethers on the Pi. You can use a symbolic name here, and then of course you have to put the IP address in etc. hosts. And this is what RARPD looks for. It looks in the MAC address, looks in etc. hosts. Now, you want to tell it to just go after the Ethernet port and not the wireless port because you don't particularly want to be trying to boot the internet. Restart all of this, and you fire it up, and sure enough, now it's a little strange. I don't know. You've played with Spark Classics, maybe you know. It starts up, and it will first try to boot off the AUI port. And then after a while, it realizes, oh, there's nothing there. Then it switches over to the RJ45 and actually finds, they call it TP. Twisted pair. Yeah, it took me a while to figure out what that acronym meant, but anyway, it does that. I don't know. I couldn't find a switch in the open boot prompt to switch it over to say, no, don't do the AUI thing. I don't know. Anybody? Okay.
I don't think my IPX behaved that way, but it's different.
Did the IPX have?
It didn't have twisted pair.
It didn't have twisted
Oh,
pair.
I'm sorry. Yeah, I was wrong on it. Yes, thank you.
Yeah.
IPX had twisted pair. It didn't have AUI.
Okay. Interesting. Yeah. Having both of them. I originally had
a comment reminded me. I was booting off and having no part anyway.
Okay. So the point of RARP is just to give the IP address to the Sun. And so that's kind of not enough, and we'll get to the more stuff that you got to do in a moment. But the next thing you need to do is start up a TFTP daemon. TFTP is what Sun uses to load the second stage bootloader over the network onto the device so that you can then suck in the proper kernel and so forth. And so again, what you need to do is go in and poke the thing properly. There are a number of TFTP servers, but they don't all work with the Suns. This particular one did. And so get this particular one, configure it this way. TFTP boot is going to be the root directory for all of this. Configure a few more things. Create the directory, it complains if it can't find it. Restart the daemon, you're ready to go. Now, right. Okay, so we have RARP to give the IP address. We have TFTP to send over the second stage bootloader. What the Sun does is then actually send out a broadcast TFTP request saying, I'm looking for this file, can you give it to me? And because it doesn't know a router address or whatever, all it knows is its own IP address. So, and the way it does that is it takes its IP address, converts it into hex. So CO A8010A, I arbitrarily picked 110 as, picked 10 as the name for it. And then the Sun 4, it appends its architecture. The Spark Classic is a Sun 4, Sun 4M, I should say. So you go and find the 102K bootloader, which is called yeah. Oh, I'm sorry. Yeah, it's called boot.sun4m. You've got to extract it out of the tar file that's there. Then you can go and stuff it in the TFT boot directory. So now it'll get to the second stage, bootloader, when things start getting interesting. Now, with modern DHCP, you send out a, tell me who I am request, and it sends back a whole bunch of crap, including things like routers and name servers and junk like that. That's really useful. Sun just used RARP, which only gives you the IP address. So there's extra junk you need to send back. So the way Sun did it is they had come up with RPC. This is remote procedure call. Thank you, which is a pretty heavyweight protocol, and they threw it at everything. And so they said, oh yeah, we need to do network communication, RPC. So there's this boot param daemon that you need, a server, and what it will do is send back additional configuration parameters to the device that it's asking for. And in particular, it will tell it where to find the kernel and also the swamp file, both of which are compulsory. So configure up boot param d, do that, create a file that we're ultimately going to serve to it, and then create an empty swap file. I arbitrarily chose 64 meg. I probably should have made that a little bit bigger. Anyway, so this again is quite a challenge, and boot param d is basically only useful for old Suns. Fortunately, it's still in the Ubuntu distribution. Now, what's going to happen is Sun's second stage bootloader actually sucks the kernel down using NFS. Now, that's kind of surprising. Yeah, of course, because it can. Yeah, Sun created NFS, so you got the hammer, that's the nail. It's pretty remarkable stuff. Most everybody else sucks kernels down using TFTP because, why do it anymore? Anyway, this gets pretty fancy. Okay, to build a diskless machine, the trick is you've got to have a full working, happy root file system on the server. Now, the trick is, how do you create that file system? The usual way is that you'd have some installer program that would start up on the machine normally, and then it would go and populate that for you. Now, if you're trying to do this on a Pi, necessarily you don't have a running Sun yet. And so there's this sort of, how do you bootstrap the bootstrap process? Well, it turns out with SunOS 4.1, it's actually simple enough to grab the install media and create that root file system yourself. And it's sort of interesting to see how that works. I tried to do this similar process with Solaris, with the later Solaris release, and realized, no, this is not for mere mortals. Because you have to understand Sun's weirdo package system and all the rest of that. And it's one of these things where it's difficult to generate it otherwise. There's probably a way to do it, but I ran out of time. So instead I did this. So the next bit is building up a root file system for this. Now, what does the root file system need? First and foremost, especially in the case of Sun, it needs the kernel program itself. So that's not too difficult. But there's a whole bunch of other stuff you need as well. And so this is the recipe. You go to the root file system, you extract the proto-root, and this is what's neat about it. All of the files on this installation CD-ROM, they're tar files. And we still have the tar program. It works fine. We use it daily. It's great. And so it's really nice. All you have to do is run tar on the appropriate, they just called it KVM and not kvm.tar or whatever, because they knew everything's a tar file. Anyway, so KVM is binary, sys is some other stuff. Then there's a whole bunch of other things, exec, share, all of these need to be unpacked and stuffed in that directory. It looks for the kernel, let's see, at the top level, and for whatever reason, it gets unpacked into KVM stand VM Unix. So you've got to link it back up to the top level directory. It's kind of like, hey, the kernel is there, you're just looking in the wrong place, and someone says, I don't care, it should be there, go fix it. So this is how to fix it.
They didn't want to implement path traversal in the second stage bootloader. That's probably why. Probably. But they implemented frickin' NFS in the second stage bootloader. It doesn't seem like a big jump. They implemented version 2 and only the read operation, so.
Yep, okay, fair enough. Now, this is the kernel. This is the first thing that runs, and the most important thing that runs. However, its job is to run the init program. And it looks for that in a very specific place. Wants to find it, let's see, oh yes, in sbin init is where it happened to look. But of course it isn't there, it's actually in user, etc. init. So again, the symbolic link solves that problem.
That's a usage of link that I haven't seen before is if there's no second file parameter.
Oh yeah, then it takes the base name. So what this does is links this thing to a file in the current directory called init as well. So yeah, it just oh, okay.
I mean, if you do a single argument,
Oh.
destination is implied being dot.
Okay.
And it's
Yeah.
dot.
Yeah, that makes sense. Well, it does a little bit more than dot, right? It picks off a name as well.
That would occur also if you were to type dot.
Okay.
So, if I could hold you here for just 1 second.
Yeah.
I think you said they implemented NFS 2.
Definitely version 2, yeah.
Alright.
Yeah.
Are we going to get to any complications with that later, or am I jumping the gun? Haha.
Yes.
Okay.
So one of the things you have to do to tell the NFS server is, allow version 2. And furthermore, this was the problem I found with Raspbian. I'm not 100% sure, but I think the way the NFS server is default compiled there, it doesn't have support for NFS 2. And so rather than recompile the NFS server into Raspbian, I said, screw it, we're going to go Ubuntu. So yeah, every one of these things, there's little gotchas like that. Anyway, this is really fun. So we're building up the root directory for SunOS. We need devices. And they're not all artificially, pop into existence like they do in modern Linux kernel stuff. You actually have to put them there old style. Now, this is the great thing. There's this makedev script that's just a bash, that's just a shell script hanging around in the dev directory that got unpacked. And the shell under Ubuntu can actually handle running that script. So this seems innocent enough, but this is actually running 1980s, 1990s Sun software on a 2019 Ubuntu release. And it actually mostly works. It gives you one complaint about not being able to find mocked or something like that, but then it seems happy about it. Anyway, standard things. I think you absolutely have to have dev null to be able to do one of these things, and if you don't have it, we'll complain about that. Sudo TTYs, win0 is what you need for SunView. And then one other very, very important incantation is turning off, later it was called NIS, Network Information System. Earlier it was called Yellow Pages, which was a lot nicer, and then somebody sued him and said, no, Yellow Pages, I think, was trademarked in Europe or something like that, so that they had to change it. But unfortunately, everything is still called YP.
And then burn it with fire.
Yeah. Oh yeah. No, it's don't touch it. Really. Anyway, okay. Then you've got to go and configure the FS tab on it so that once it's mounted the root file system, it can successfully remount it, or at least tell you that you don't need to remount it. So tell it about, and it needs to know both / and user being mounted. And then it's nice to tell it about itself and the NFS server that you're going to use for actually serving the files on it.
So, quick question about disabling YP.
Yeah.
Were you able to get DNS to work with that? Because when I last tried SunOS 4.1, the only support for DNS was as a bolted-on component of YP.
So I've not played with that.
Okay.
I remember it's something like that, or some wacko patch or something like that. Yeah, this is sort of all pre-DNS days. So it's a tricky thing to get working.
Well, the Ubuntu should still supply an NIS server that's compatible enough to send to host snap, so you have host resolution, even though it's not DNS.
Yeah, there's probably a way to make it all work.
But you have to configure the YP
Exactly.
services on the client host
Yes.
to talk to it, and that's just don't.
That's not that
But if you
bad.
don't do it, then you get no
I'm still
DNS.
thirsty over it.
I'm still running it at work.
I think there's a way to patch. I think there's also a way to patch the config, the resolve system, so that it goes after it in sort of a reasonable way with DNS. I can't remember exactly. I didn't get that far. The fact that I was able to boot and actually open a GUI on this thing was pretty dramatic. Yeah, spoiler alert. Okay, NFS is the only protocol in all of this that is still very much used today. Now, not V2, but overall it still works fine, right? And this is great. It's either a kernel server or whatever, and the configuration is actually not bad. All you have to do is change, etc. exports to tell it, okay, send out SunOS to Spark Classic. And so this is not a huge security risk, it's only a minor security risk. Turn on version 2, like I mentioned, turn on all the debugging you possibly can because it's going to go wrong, you want to know why. You fire this thing up again and you're good to go. And my God. Let's see, so the first thing that was great was when this stopped doing it and actually managed to run it properly. That was a great thing. This is the TFTP second stage bootloader going down. This was also a major, I forget how old the scotch was that I drank that evening. It was, and it jumps around a bit and says, oh, I can't do this. And it seems to keep going back to the AUI, even though we're doing twisted pair the whole time. Here's where it's using boot param and figuring out all the rest of that. And then this is a joyous thing. Here's where it's actually sucking in the kernel through NFS to run. And this is just the coolest thing. And it's this vertical bar / slash backslash spinning around. It just, oh my God. Wonderful thing. You got a question?
How'd you do that video capture?
That's pretty good quality.
Yeah, it's not bad. I messed with it quite a lot in GIMP to get the to make it look reasonable. But yeah. Anyway, I mean, I'm going to show you more console porn here. This is the kernel being loaded. This is probably the greatest thing I've ever seen in my life. When this is the kernel actually starting up and saying it found all of this junk or whatever. Then it goes and remounts everything, goes and gets the NFS stuff or whatever, checking file systems, that's just awesome, blah, 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 blah. And then it finally gives you a login prompt. Yeah, it's like, oh boy, this is pretty wonderful. Let's see, it looks like there's an RDate server, which I should probably put on the PI as well to make it work, but hey, whatever. Just because I can.
So what's the root answer?
Empty. Okay, and so what's fun, so to debug all of this stuff, it's a combination of you use TCP dump to really look at the low stuff, but then also look carefully at syslog and make sure that you've got all the debugging turned on for all of these things. So here's RARP sending the IP address. Here's TFTP serving the second stage bootloader with this god-awful thing. Here's boot param D telling us what's what. And then here's NFS mounting and then serving up the kernel. Boot param D actually gets queried a number of times, so the kernel is the most important thing. It also gets swap, and it seems to need swap no matter what. There's also /dump, which you can leave out. And then here's finally a init running and mounting these things again. And again, it's a joyous thing when all these things come together. And there you go. There's the punchline, and all of its late '80s, early '90s, wonderful. Just not the worst GUI ever, but pretty bad. But you can run programs on it. So what the heck? Let's see, I think I already mentioned, for more porn like this, come visit Unix Town, and I've got the Spark Classic and the O2 that I'm going to show you in a moment, working and making all that work. Now, the critical thing about doing this with the Spark was that for as complicated as this business is, which is populating the root file system, it's actually pretty easy. This is basically me faking the Sun installation process. And the fact that you can put it up on 2 slides is actually pretty remarkable. The trick is that you get much fancier than that. You can't really easily do it from installation media. And so my next opponent is the SGI-02. Here's a naked one. And the reason it's naked is probably not voyeurism, but the plastic on the outside of these SGIs just turns into dust at this point. You know, one good sneeze and all the little things holding it together just go all over the place. So, kind of scary stuff. Okay, a little bit later, SGI, 1996, 180 megahertz, baby. Another 32-bit RISC processor. God-awful, proprietary, pretty fast for the time, but impossible to find any more. 239-pin memory DIMMs. And so basically you get those by ripping them out of other O2s. Kind of unfortunate. Ultra-wide SCSI drives, these were the last gasp of SCSI, or this was the design, the last version of SCSI drives, because before everybody said, oh, screw it, this SATA and SAS drives are much better. 100 base T Ethernet, not too bad. Pretty respectable video, 75 megahertz. So again, most of my VGA LCDs could handle it, but not all. The real reason to play with these things was the graphics ASIC that it had in it. And this is pretty heady stuff for 1996. Hardware texture mapping. So pretty cool stuff. The other thing that's really neat about it is that although I have an SGI keyboard and mouse, they're just PS2 mice and keyboards in extra fancy colors.
Are they really on the O2?
So far as I can tell.
Yes. Because on others they are not. You
No,
can
it's
connect
just
yours
the
to the same.
older Onyx, the old ones.
All right, because my Indigo 2 is definitely not.
Yeah.
Indigo 2 is PS2.
Is it
Indigo is
Oh.
a non-proprietary.
Oh, right.
It looks like
Yeah, they changed it. This one I've been able to use stock PS2 keyboards without difficulty. Can't speak for the other ones.
Ultra Sparks also can, but a few keys are not present on normal PS2 keyboard.
Oh, okay. Yeah, with the Ultra Sparks.
Ultra
Yeah,
Sparks,
Yeah.
not a 30
Yeah.
Spark.
yeah, no, that makes sense. Anyway, so as much as I'd like to run this thing diskless, there's this problem of how do I get the root file system on the Pi? And I could not easily figure out a procedure to go from the SGI installation media to that root file system because they have their own proprietary packaging thing or whatever. The way, if you go look at the documentation, they say, oh, it's easy. Once you install the operating system, then do blah, blah, blah. So you can't bootstrap that way. Okay, very similar procedure. Here's what it looks like. And oh, by the way, the O2 has the best boot sound of any computer I've ever seen. You got to hear it. Okay, now, again, like any proper workstation, it has a command monitor built in for booting and so forth. One of the things you do is clean up whatever mess the last guy made. And then set things. And we were talking about this during the break. One of the strange things you've got to do is tell it its IP address here so that it can then confirm through another protocol that what you told it here was correct. And if you tell it something wrong here, then it doesn't work. So unfortunately you have to assign it anyway. So not very dynamic. This uses bootp, which is sort of a proto-DHCP. In fact, many DHCP servers will revert to bootp if asked, and they're built on top of each other.
So you can reuse the same UDP port.
Yeah, it's they're one is a direct connection to the other. And so in fact, we're going to use a DHCP server to set that up. Here's how to configure all of it. We're going to call it the hostname SGI-02. Let's see, this is the subnet. We're going to go after the 192.168.1 group. And this is the MAC address of the SGI-02 I happen to have, and we're going to put it at 1.11. And so this is great. I've got this little network where these two machines are booting off the Pi, and I'm hoping to get a third at some point. Okay, now it uses TFTP again, and this is nice. You don't really have to configure anything differently. You just need to make sure that the appropriate files are copied down. Now, SGI, its second stage bootloader, excuse me, we're doing install, we're not doing boot. The installation program looks like a second stage bootloader. And it's called SASH, for standalone shell. ARCS is SGI's name for 32-bit MIPS, which is a 64 version of it. And this took me a long time. Normally, this installer is hiding in a separate partition on the CD-ROM drive that's written in a file system format that is apparently only known to the SGI bootloader. In particular, it's not EXT or XFS or EFS or anything like that, so you have to go and find this somehow. Anyway, this is the magic incantation that does this. This copies a whole bunch of other things. The installer SASH, the disk partition FX, and then there's a self-test program called IDE that does a bunch of exercises as well. Now, SGI uses RSH to serve installation media. RSH is, what is it? It's supposed to be remote shell. It's more like, ridiculously insecure shell. You should not be running this today on an open network that would get attacked immediately. Anyway, let's see. I think its password's getting sent over in clear text and just sort of
It's
nightmare.
address authenticated.
Sorry,
It's address authenticated.
it can be address authenticated.
Now, RSH is only address authenticated. Our login has the option to do both.
Ah, okay, fair enough.
What could possibly go wrong?
What could possibly go
Well,
wrong?
if you run it over IPsec, it's actually perfectly fine. Get out. Just
Right. So you create a fictitious user, SGI, actually you can name it anything you want. Tell it our hosts, and here's where it's IP address authenticated. We don't put a password on this thing and then fix up the things. We're going to create an SGI user on the Pi that the SGI installer will be able to go and use RSH to copy files down. Okay, there's a lot of install media. This was at the point where CD-ROM existed, pretty ubiquitous, but they already were getting too small for the application. So you've got to download 15 of them or something like that. Let's see, my favorites, do I have the right? No, oh yeah. 1, 2, 3, 4, 5, 6, 7, 8 CD-ROMs seem to be necessary, and there's probably more that you need to get. But I don't know, I've read this is actually a really fundamental SGI install problem. When do you have enough CDs? And I don't know, if people have good ideas about how that should work, I don't know, but this was the closest I was able to get. Anyway, what I do is, once you've unpacked all of these things, you can mount them under Ubuntu. You just have to warn it that it's using this EFS file system, which is SGI's own thing. These things will all show up in the SGI directory, and as a result, all you got to do is remember sort of what this path name is, so that when you run, let's see, so first thing you do is you got to run the partitioner if the drive isn't just right. Here's the installer starting up, and this was an interesting thing. The version of the installer that I downloaded seemed to be very, very interested in using tape. And it took quite a while to figure out that what you need to do is tell it that the tape device is actually a file that you get at via TFTP, despite the fact that this is BootP. Anyway, that was fun to debug. Anyway, this is just a wonderful, wonderful thing. it does two things. It goes and copies SA, which is the bigger installer, off of it. And it downloads a mini root that it then stuffs on the future swap partition, mounts that as a file system, and then fires up the full blast installer. And then it starts looking like this. It created a new file system on the newly formatted disk I had, or newly partitioned disk I had. Let's see, it said it was happy. Then what you have to do is tell it about all the installation you need. And this is the magic incantation. User SGI at 192.168.1.1, that's the Raspberry Pi. Found 1 is the directory where I mounted that ISO, and then dist is the distribution stuff in it. So you have to tell it about all of this stuff. And then it starts getting happy. You start running the installation. You say install. You get 500 conflicts that you hope can go away. And this is the second big problem in SGI, which is related to the first problem of, do I have enough installation disks? And getting rid of these stupid conflicts. It's not the worst user interface I've ever played with, but it's top 10. Pretty scary. Finally, you get it down to nothing. You tell it go. You don't just go get coffee. You go and roast the beans, grind them.
Stopping UPS is impossible.
Yeah, exactly. It's patience is advised at this point.
It probably goes faster if you use an emulated SCSI disk as well.
That's probably true. It would probably go even faster if we used an emulated SGI. Really good. Now, the one other interesting thing is, as soon as you say quit, I didn't bother to put this, but in fact, you can go get another cup of coffee, because it goes and does something. It goes and fixes the ELF files, quick starting. I don't know exactly.
Like pre-links them, I think.
Yeah, or it may do something like that. It reminds me a bit of when you update Android. What happens is it goes and recompiles all the Dalvik files or something like that. Anyway, so here at least it's a little bit more honest about it, saying, "Oh, running quick start, go see this man page," as opposed to Android, which just says it optimizing applications or something like that. Anyway, you can go and take a look on syslog. Here's bootp feeding the IP address to it. Here's TFTP sucking in the second stage bootloader. This is the sash arcs file. SA is the installer, and then here's the mini root being dragged down and stuff down here. And then you can watch the RSH logins, which are actually reasonably complicated because there's a lot of files falling back and forth. Okay, thank you for your attention. I'm nearly done here. Now, like I say, I'm an academic, and so all of this I presented this as, oh, yeah, piece of cake, it just kind of worked or whatever. And of course not. Every line of every config file represents like an hour of frustration of mine, right? I try this, why did it fail? It's not doing the right thing. It's always it'll give you an error message, but it would be more helpful if the error message was actually in Chinese, because you then wouldn't try to decode it, because it's generally not telling you what's going on. So like the tape, figuring out the tape thing, it was, oh, could not find this file. Oh, another one that was really good was, should you have bootp in format of the file, like the sash arcs file to boot? And the problem is that if you do that, and if you give it a different file name on the command line, it says it can't find that file because it was actually looking for the other file that you were just mind-blowingly bad. Let's see, so I mentioned this. I tried also with Solaris 2.3 and a few other Solarises. Solaris I don't know. Yeah, Solari.
If you're going to netboot Solaris, you've got to use Jumpstart, and even you can actually get a basic Jumpstart service set up. You can do a basic install with a few lines, and it's not hard.
So the question I have for that is, well, Yeah, to do the install. So a procedure like this would work to install Solaris, but I wanted to go one step further to actually do it diskless. And the difference between the two is for the install, you just have to make sure to serve the install. And that, you're right, that's not too difficult. The jumpstart stuff, that could all work fine. So if you wanted to do kind of what I did here with the SGI, where you had a sun with a disk, and you wanted to put the operating system on, in fact, that works pretty well. If you want to do it without a disk, you're left in this position where you need to run the sun scripts to set up the root directory. And of course, the whole point is you don't have an operating sun at that point
Yeah.
to
What,
make it work.
what does Jumpstart run on though? Doesn't that require Solaris already? You can't run Jumpstart on Linux, can you? Like
No, Jumpstart
Jumpstart's like
is
the
it's just a diskless install, or
but
it's a network install.
It's a lot of what you did in your.
Yeah,
Yeah.
but it
yeah.
runs.
No, it's very similar. The main difference is
But I'm
that-
saying, does it assume that you already have Sun to run the Jumpstart server? In this case, you
Yeah.
don't. You're starting with Raspberry Pi. so
Yeah,
how
I
do
think
you
it's,
build
I
your
think it's
Jumpstart
still
server?
easier. I was able to get it to the point where I could fire up the Solaris installer, and the jump between that and getting Jumpstart working is a pretty small one. So yes, I'm confident that the same procedure could be followed. But damn it, I wanted to run it without discussing this. That was the challenge. Anyway, the SGI was so like I said, net install would work fine, but then you got to have a hard drive. Now, my original goal for all of this was, in fact, to run this not on a Raspberry Pi, but on a consumer wireless router that I pulled out of the trash. These are interesting little monsters. They all run a small version of Linux. Most of them run proprietary ones that you can then kick off and install a wonderful distribution called OpenWRT, which is this kind of amazing, mind-blowing little thing that boots off of, let's see, like 3 or 4 megabytes of compressed file system. And it does all kinds of crazy stuff to make this all work, but the result is you've got a Linux command line that you can install packages on and all the rest of it. The problem is that it doesn't have a wide enough set of packages to do archaic Sun stuff. I got so far as to figure out how to compile boot parameters. I was able to compile the burp daemon under OpenWRT. I thought that was pretty cool. Then I got to boot param d and just gave up.
They do have a pretty good software development kit. I mean, or whatever platform development. You can make packages pretty readily.
It's not too bad, but the problem is boot param requires all of the RPC stuff as well, and at that point I was staring down the deadline. That was the end of it.
So I just want to put it up plus one version of your.
Yeah. No, it's a wonderful toy, and especially one thing that's really quite practical is Pixie is the modern version of all of this that's reasonably standardized, and all of your laptops can do this, and all of your modern desktops can do this, and so forth. And that works pretty well. Yeah.
OpenWRT and has, I don't know if it's a fork or a competitor or whatever, but there's DDWRT. And both of these are great platforms for bringing a lot of life to old, like garbage, Linksys routers.
Exactly.
And one thing with a lot of things you buy, like at Best Buy or off the shelf, is these boxes are very powerful, but they have very limited functionality. In OpenWRT and DDWRT add a lot more features.
Oh yeah, no, they're wonderful stuff for people like us who aren't afraid of doing network configuration and so forth. Another thing that's wonderful, I was going to bring in, I bought a couple of these things. So this is a router, it's about like this, about 16 bucks from a Chinese website. And it's basically a Linksys caliber router, right? Two Ethernet ports instead of 5 with full Wi-Fi or whatever. You power it off of a 5-volt USB thing going into it. And it's great, it's 32 or 64 megs of RAM, 8 megs of flash, runs OpenWRT like a champ.
Oh,
Yeah. So that particular one,
They're all over eBay now.
there's a whole bunch of them. I'll figure it out later. So it's not a TP-Link, it's even more extreme, but you can do it with TP-Links as well. If you go to the OpenWRT website and look at the support stuff, it's pretty good. Let's see, why don't I end with acknowledgements? So a lot of this stuff, as was talked about earlier, right, the booterizer stuff is down here. I didn't run this stuff as usual for more documentation, read the source code. So I went in and tried to figure out what the hell they were actually doing and what servers they were spinning up and keys they were spinning up and so forth. Anyway, there's a bunch of web pages that have tutorials on all of this that made it all possible. And so the novelty here was just making it all work with a Raspberry Pi and doing it on 2 of them at once, which is kind of neat. They actually did mesh nicely. And like I say, the advertisement is if you really want to know, come and see my presentation in Unix Town. Unix Town is incredible. There's some things that kind of go against nature, like a Lisa running a Unix operating system. I mean that kind of pains me, but it's still a neat thing. Anyway, thank you so much for your attention.